Hi grade 11s. Today we are going to be learning about what's called heats of reaction. And this is lesson 2.12. Okay, heats of reaction. Heats of reaction can also be called, another word for this is enthalpy. And that's something, so that's E-N-T-H-A-L-P-Y. That's another thing that you will learn in your grade 12 chemistry course as well here. Okay, so basically, all reactions are going to involve a change in energy. So an exothermic reaction, this is where energy is released, and these terms are things we've talked about before. So exothermic energy is released, endothermic energy is absorbed. And so if we were to write a chemical equation, exothermic would be the reactants is going or yielding products plus energy. So this would be our energy is released, so it's going to be on the product side. And then the opposite of that for endothermic, we're going to require energy to make the reaction move forward. Now, heat of reaction, this is the quantity of heat transferred in a reaction. So there's always exchanges of energy. Remember, energy and heat are the same words, or mean the same thing, I should say. So we have something called delta H. So delta H, this is called the molar heat of reaction, or the enthalpy change here. So the unit is going to be kilojoules per mole for this, and this is just showing, you don't need to copy down this graph or anything, but this is just showing at this particular reaction here, you've got reactants, and then as time goes by, it goes all the way up, so this is what's happening to the energy, and then we're ending here with the products. So there's heat is going to be released by this particular reaction here. And yeah, don't worry too much about this is sort of a grade 12 concept here, but I just wanted you to see that graph there. Okay, so we're going to approach this on a really basic, just stoichiometric level. We're looking at the balanced chemical equation, and we're looking at the energy either released or acquired, and then we're going to calculate it, okay? So we're going to work through an example to show how this works, because energy is going to be released or absorbed based on the mole ratio. So it follows that mole ratio, so we can follow the balanced chemical equation to solve these. So the question is, calculate the energy generated by the reaction of, and then I've got 3.6 grams of methane and an excess of oxygen. So remember, when we say an excess of something, that just means you don't have to worry about it, right? Now, it tells me that I've got 3.6 grams of methane. So looking at this, sometimes people are like, well, which one is methane? And you're going to figure this out just by process of elimination, right? You know it's not water, you know it's not carbon dioxide, and it's not oxygen. So it has to be this one here, this CH4. So I've got 3.6 grams of this, and I'm looking to calculate the energy. So this equation is balanced already for me here. So what this tells me then is that there are 878 kilojoules released for every 1 mole of methane, for every 2 moles of oxygen, for every 1 mole of carbon dioxide produced, and for every 2 moles of H2O produced. So I'm going to factor in that mole ratio here. So we're going to use dimensional analysis like we always do. So energy is going to be equal to 3.6 grams of ethane. Now, as per usual, I can't do anything with that until I turn it into moles of methane, because in chemistry we always work through the mole. So grams of CH4 goes on the top, moles of CH4, sorry, I think I said top, goes on the bottom, moles of CH4 goes on the top. So in 1 mole, how many grams do I have? Now this number comes from the periodic table. This is going to be 12 plus 4, this is going to be 16.04. So right now I'm in moles of CH4. So now I need another bracket to get into energy. So 1 mole of CH4 goes on the bottom. And then I've got the energy here. I've got 878 kilojoules for every 1 mole of methane produced. And then I can work that out, and I get an answer of 197.06 kilojoules, and I can only have 2 sig figs though because of that 3.6, so I'm going to put a bar over the top here, or if I had to round that, I would change that to 200 again with the bar over there, kilojoules. Okay, so 2 sig figs for this particular question. Okay, next question here. This is for the combustion of 2.4 grams of octane. So just so everyone knows, it's fair game for me to get you to write a combustion equation, right? So you do know the different types of reactions, you know the products, so you could be asked to do that, okay? So the combustion of 2.4 grams of octane. So again, I've got 2.4 grams here. And what is the heat of reaction? So when I'm asking for heat of reaction, I'm asking for energy, okay? So energy equals, I write down what I know, 2.4 grams of C8H18. Now, my very first step is going to be to convert that into moles. I need to get to moles because it can't go anywhere without going through the mole, right? So I'm going to have grams of C8H18 on the bottom, and then 1 mole of C8H18 on the top. And now I'm going to calculate the molar mass from the periodic table. So 8 carbons and 18 hydrogens, and I get 114 grams of the octane. So right now if I stopped, I'm in moles of C8H18. So I don't stop because I have to get to one more spot, and I have to get to energy, right? So kilojoules goes on the top, and I've got 10,148 kilojoules for every, and then here, this is going to be moles of the C8H18, but now the question is, what number goes in here? Now, this amount, I'm just going to use a different color so you can see, this amount of energy is for 2 moles of C8H18. So I'm going to put a 2 there this time. So you have to look at your balanced equation to figure this out, because that's going to give you your mole ratio the ratio between the energy and the moles of the octane. So now you can work it all out, and you end up with an answer of 106.82 kilojoules. And again, we want to look at sig figs. I can only have 2 sig figs because of that 2.4 grams. So I'm going to put a bar over top there, or I can round that to 110, oops, not grams, kilojoules. Okay, so this is pretty much the only way we're going to be doing these questions. Yeah, I'm not going to ask you anything else. It's always going to be just looking for the energy. So your assignment is going to be exercise 18. And let me just check here. Yeah, I think there might be an error on one of the questions, maybe question 2. Anyways, there's a missing piece of information, I think, somewhere. So if you stumble across that, don't panic. There's just a mistake in the question. Okay, thanks, everyone.